This is the solution for question 20 of section 2 in the practice SAT. In this question, we're told that for all real numbers a and b, this expression a dot b is defined to be a times b plus a plus b. These sorts of questions appear somewhat frequently on the SAT, and they tend to confuse students who are not clear what this little symbol or some other new symbol might mean. All it really is a function of two variables, not much different than plus, minus, multiplication, division. It says we take the first number and multiply it by the second number, add the first number, and add the second number. So for example, if we were given 3, circle dot 4, that would be equal to the first number, 3, times the second number, 4, plus the first number, 3, plus the second number, 4. In case that would be then 12 plus 7, or 19. Now in this question, we're asked to determine if three statements are true. The first one is, does x circle dot y equal y circle dot x? The easiest way to do that is just to substitute x and y in for a and b in the expressions and determine if they're equal. So first we'll do what's on the left-hand side. X circle dot y is going to, now again, x plays the role of a and y plays the role of b. Substituting that in, we'd get first the product x times y plus x plus y. And on the right-hand side, we get the product y times x plus the first number y plus the second is x. And we can see that these are indeed equal to one another. We have an x over here and an x over here. We have a y here and a y there. And yz here is equal to xy. So this statement is true. The next one we're asked is x minus 1, the quantity, circle dot, the quantity x plus 1. Does that equal the quantity x, circle dot x, minus 1? So again, just doing the same thing we did before, substituting x minus 1 for a and x plus 1 for b. First the product, x minus 1 times x plus 1 plus the first number, and then plus the second number. X minus 1 times x plus 1 is the difference of, it's very similar to the difference of squares, and that's going to work out to be x squared minus 1. And now we can just drop the parentheses here, plus x minus 1 plus x plus 1. Do a little simplification on the left here, and we get x squared plus 2x minus 1 minus 2, then adding another 1, it's going to be minus 1. So now we want to know, how does that compare with the right-hand side? In this case, on the right-hand side, we get x times x plus x plus x minus 1, which is x squared plus 2x minus 1. And we can see clearly we have an x squared here and x squared here, 2x here, 2x here, minus 1 here, and minus 1 there. So this also is equal. Now we can do the same with the third expression. Again, in the left-hand side, this plays the role of a, and that plays the role of b. So first the product, x times y plus z plus the first one, x, plus the second one, y plus z. Simplifying this, distributing x times y plus x times z plus x plus y plus z. Now let's look at the right-hand side. First, this expression, x dot y, is going to be the product, x times y, plus the sum, x plus y, then plus the product, x times z, plus the first number, x, plus the second number, z. And now we need to see if these two expressions are equal. Let's put these in a little more common order. xy, now I'm going to put plus xz, and now I have plus 2x here and there, plus 1y there, plus a z. Now comparing these, I can see that, yes, I do have xy, I do have an xz on both sides, have a y on both sides, a z on both sides, but here I have 2x, and on the left I only have 1x. So these do not equal each other. So for this question, only Roman numeral 1 and Roman numeral 2 are true.